experience with security in your software development process, but not at all with compliance? You want to listen in then as Liran Haimovitch of Rookout talks about managing software development in a high compliance environment and getting your SOC 2. They had very little public documentation on how to become SOC 2 compliant, but they still built SOC 2 procedures around Agile software development and DevOps and attained certification in less than 6 months. Really worth listening to.
Hi, everybody. It's great being here at GitLab Commit. My name is Liran Haimovitch, and I'm a co-founder and CTO at Rookout. Today, I'll be speaking about my journey with SOC 2 and other compliances. So, to give you some background about myself, before founding Rookout, I've been a cybersecurity expert, doing a lot of work around research and development of cybersecurity technologies, which was kind of how I transitioned to taking over security at Rookout as I founded it. Over the last 3 years, I've been speaking and writing a lot about modern software methodologies such as Agile, DevOps, and Lean. And today, I want to discuss how the two can coexist. How can you go for DevOps? How can you move fast and be agile while still meeting your compliance requirements? Now, to better understand why is this such a big issue for Rookout, I want to show you a bit about what we're doing. Rookout is a secure platform for live data collection and debugging. Using Rookout's non-breaking breakpoint, engineers can connect to their source code as it's running remotely in the cloud, on-prem, in staging, even in production, and collect any piece of data on the fly without writing more code, without redeploying, without restarting. Just click on a button and get the data you need. To do that, you install Rookout's SDK and you load your source code from GitLab or other source providers, then just throw a non-breaking breakpoint, much like you would in your local IDE, and get the data you need. As I'm sure you know, and I'm sure you can understand, this requires a degree of trust. I mean, to install us in your production environments to allow us to collect data on your behalf, you have to trust us. And while we take security very, very seriously, and we've done that from day one, we found that achieving compliance was critical to allow organizations to adopt us. And so over the last 2 years, we've gone through HIPAA, SOC 2 Type 2, ISO 27001, and we are also providing DPAs for GDPR and CCPA. This is quite a lot to achieve in that time frame, and it comes with not without friction between security and engineering. And working with other organizations and other engineering leaders, I'm seeing that it's engineering leaders who are worried about security are usually coming at it from one of two angles. The first, they are leading a small organization that's growing and needs to achieve more compliance. And so they're trying to learn about compliance and see how they can adopt it while maintaining their growing and agile development team. The other approach is often from engineering leaders in larger, more established firms, or trying to adopt DevOps and Agile while still maintaining their existing compliance needs. And both cases are about figuring out how the two can coexist. Going back 2.5 years, as we were just starting out our compliance processes, I sat down with our head of DevOps at the time, and he shared with me his own personal story of going through SOC 2 Type 2 at the previous employer. And he actually said he almost quit his job. And that wasn't very encouraging for me. So together we went to meet a few friends who've gone through SOC 2 Type 2 at various companies. And we've met with our auditors, and we kind of came up with a plan of how can we make it both of them happen together. Now, to give you some context, compliance is mostly about governance. It's about proving that you as engineering leaders know what's going on within your organization and can prove it to the auditors, and to your customers. Now, this may often clash with DevOps as we can see in this quote by Nicole and team from State of the DevOps report. Our own research has found that an organizational culture that optimizes for information flow, trust, innovation, and risk sharing is predictive of software development organization performance. So if you want DevOps, you should go for trust, you should go for risk sharing. But if you want governance, you might end up with this quote saying, in business, we often use the more politically astute term governance instead of control. Now, Reed Eschler goes on to explain that governance is not control. Governance can be achieved through control, but in our case, we're trying to achieve governance without control. We're trying to see how can we let trust live side by side with governance. And that might sound like a bit of a conundrum because on the one hand, we want to tell our engineers, we trust you. On the other hand, we want to tell our auditors, we know exactly what our engineers are doing. And to solve that issue the DevOps way, let's take a quick look at some of the principles of DevOps. In this case, I've taken them from See the Whole blog. And you can see that while trust is a big element in the social aspects of DevOps, there are also other principles, such as quality assurance and measurement, that do allow us to know what's going on, even though we trust and empower individual contributors. And to see how we facilitate governance through DevOps, we've kind of built this framework at Rookout. And so whenever we go through a new compliance, whenever we go through a new set of requirements, we first of all ask ourselves, is this requirement currently being met through a DevOps process we have in place? If so, then that's great. Document the risk and document the solution you already have for it. Document the control or the process you have that mitigating the risk. On the other hand, you might find that you do not currently have a control in place for mitigating that risk. This is a good opportunity to mention that, as you all know, DevOps is all about continuous learning. And so you should think of this as a learning opportunity. An industry expert is letting you know that this is a significant risk and that you should go ahead and mitigate it. Do you agree? Is this truly a significant risk to your business, to your customers, to the data you're processing? If so, then you should mitigate it. But do it the DevOps way. Figure out how to empower your engineers, how to shift left, how to help them prove that they're meeting the risk, and then document it. And we are going to go over some of those tools later. On the other hand, you may find that you disagree. This is not a significant risk for your business at this time for a variety of reasons. Maybe you're not processing that kind of data. Maybe it cannot be stolen. I don't know. But if you feel this is not a significant risk, then you often can document it. Document this is an acceptable risk and you can live with it. And there is a good chance you can convince your auditors and other relevant stakeholders that you know what you're doing and this can be acceptable. Now, going through this process, we ended up with three main pillars of compliance at Rookout. So I want to share with you them. I want to share them with you and go through them one by one. First, we have automation. Now, this is a DevOps conference, and you're going to be hearing a lot about automation through GitLab and other tools today. But for now, we're focusing on the value of automation for security. And the value of automation for security is that unlike individual contributors, unlike engineers, we have much greater control over software. We have much greater control over applications. And so if we're asking a script to execute a specific task, we have a much greater degree of control, of governance, of visibility into it than if we were to ask an individual contributor. The way we approach it at Rookout is by building a portal, which can be GitLab or another tool. We grant our employees access to that portal, each based on his role, and then we implement with various tools that execute the tasks we need executed. It can be deploying stuff to Kubernetes. It can be changing our cloud configurations. It can be spinning machines up and down, whatever it is. Implement those tools, and then employees can invoke them as needed with the entire process audited into logs. So you know who accessed this, you know who accessed the system, you know what he did, you know what operation took place, and you know if it was successful or not. And best of all, you don't have to grant your employees SSH access or administrator access or any kind of privileges to the actual production environments. Now, there are many automation candidates. Some of them include deployments and releases, which we're going to talk about more in a bit. It includes provisioning and deprovisioning of environments. It includes system integration tests, maintenance and cleanups, and backups and restores. Now, in automating for security, you have to keep in mind the principle of least privilege. Which of those operations showing up here or otherwise are executed by many of your engineers? Which of those operations require a lot of privileges to sensitive stuff? If you can find a handful of tasks that by automating, you can revoke sensitive access from engineers and they no longer need it, then those are excellent tasks to automate. And so it's much easier to prove you know what's going on because the engineers aren't accessing the environments directly. They don't have access to. And anything that's happening through the portal, through the automation, is well audited. Now, the second pillar, greatly extending on automation, is CICD and GitOps. GitLab has many tools for CICD and GitOps, whether it's the GitLab CI tool, the GitLab CD tool, merge requests, and so on. And then from a security perspective, it's all about shifting left. It's all about baking security into the process we already have so that we write and develop secure code, secure applications in the first place, rather than trying to write the applications first and then make them secure second. Some of the benefits for taking this approach for securing applications include that you get a single source of truth. Everything gets deployed through CICD, so you know what's deployed. By going through the CI logs, by going through the CD logs, by going through the Git commit history, you know exactly what went where and when. You also get the benefit of shifting left. You are empowering your engineers to secure code. Security becomes a deeper part of the system, and you're achieving it much better. Now, this brings us to merge requests. Merge requests are an existing gating mechanism within modern software development that your engineers is already familiar with. By adding any compliance requirements you have to the merge request, you ensure that by the time the code makes it to the main or master branch, it's already secure, it's already compliant. So you can go ahead and add dependency checking, security scanning, manual reviews, anything you need as prerequisites to the merge request. And then once the code is merged, once those checks pass, the code can be merged and it's compliant. This connects well with existing work processes and controls, which change how your engineers are already working. You don't have to educate them on new tools and processes. And you're probably going to be seeing much less friction going through this process, achieving compliance without driving them crazy. And last but not least, everything going through this process is fully audited. You know exactly who did what, how was it tested, and that the tests passed. so that you can show it to your auditors and show, yeah, I'm governing everything that's going on through the CICD pipeline by defining the policy, by defining how does the CICD pipeline look, by defining what's being tested through it, you achieve governance while still maintaining trust over what your engineer are doing within this process. Now, the last pillar is software monitoring and understandability. I'm sure you're familiar with monitoring, and monitoring is obviously a key factor in compliance, as you have to prove you know what's going on. But software understandability tends to be more of a challenge. Understandability is a term borrowed from the financial industry, and it's measuring how hard or easy it is for an engineer to comprehend the system he's working on so that he can efficiently and effectively fix bugs, add features, and so on. And we're going to touch on why it's so critical in a bit. Monitoring is the basis. Once you deploy to production, once you deploy to other compliant environments, you should be monitoring your software. You should ensure it's up. You should ensure it's operating. And you need to be able to show that to your auditors and in some cases to your customers. There are many stakeholders within the organizations who are looking for this data. It can be business folks, such as sales and marketing, looking to see how much revenue an application is generating, how many signups you have, and so on and so forth. It might be product and UX who are looking to see which features are being used, how. It's quite often ops and security, wanting to make sure the system is up and running and everything is running smoothly. And it's often the developers trying to better understand how the system is running so that they can adapt it to fix bugs, deliver new features, refactor it, make it faster, and so on and so forth. The tricky thing about the questions developers are asking is that those questions tend to be much more in-depth, going deeper into the business logic. And so they're asking many more questions that are about the interior of the software, not just about what's going on, but why and how is it going on. They tend to ask a different questions every time. As they're working on different features, they're working on different parts of the system, and they're trying to achieve different tasks. They have different questions. And if they have to redeploy a version of the application every time to get a new piece of data, it can be very tiresome, very annoying. And we definitely don't want them SSHing into our servers just to get answers to those questions. The data they're looking for, the state information, is often very sensitive. They might not need access to specifically the sensitive information, but those environments are containing a lot of sensitive information. And so we don't want developers wandering around, poking, trying to get the data they need blindly just to, on the one hand, we do want them to empower them to do their jobs, but we can't give them unlimited access to those environments. And so at Rookout, we found that it's important to have monitoring tools, such as logging, including Elasticsearch, APM tools for metrics or tracing, error tracking tools, and business intelligence tools to feed and provide the information all the stakeholders need. But it's also very useful to have Rookout deployed so that we can collect additional data as needed to empower engineers to better understand the system and better know what's going on when they need to. Before we finish this talk, I want to share with you some additional thoughts and maybe some things that will be very helpful to you. As you're going through compliance, as you're going through security reviews, a big impact has on the data you're trying to collect, on the data you're processing, and on the access you're asking for. Taking Rookout, for example, early in the process, we found that there are two key factors organizations are worried about when discussing adopting Rookout. The first is their source code. Some organizations don't want to provide Rookout their source code, while other organizations prefer to not provide Rookout with their application data. By finding ways to develop Rookout in a way that we don't require this data, that we can operate without source code and without application data, we avoid much of the resistance from our auditors and from the security departments at our customers, because they don't have to trust us as much. The burden of proof is lower if you're not crossing as much sensitive data. And so I encourage you to think of your own use cases. Which pieces of data can you do without? Which access can you do without? It might make your product just slightly less useful, might make your product just slightly less powerful, but it might make it 10 times easier to adapt. It might make it 10 times easier to get started with or to buy. And so think of it. Is there anything I can do without? And is this piece of data that I can do without something that's very sensitive to my stakeholders, to my customers? Will doing without that piece of data make everybody's lives that much easier? Oh, that's all I had for today. Feel free to reach out for me in the Q&A session on Twitter, or check us out at rookout.com. Thank you very much.